Hi everyone. In this section, we're only going to cover how you identify different parts of a graph and in particular applying it to a real world situation. So we're going to be looking at things like the y-intercepts, the vertex, and the x-intercepts, and we're going to try to interpret what they would mean in terms of a situation, which in this case we have Angry Birds. Okay, so if you recall, the Angry Bird game is pretty fun. Okay, so the birds get launched into the air and their goal is to try to hit the pigs and knock down their structures because they're angry at these pigs. Okay, so we're going to interpret different things about the Angry Bird flight paths as they get launched into the air and head toward these pigs, which in my opinion, I think the pigs are cute. But anyway, so we're going to be interpreting things about this graph. We have two equations and two different birds that are flying through the air. Now, it's not labeled on the graph, but this problem is about the flight path of a bird. Okay, and it's going to talk about how high the bird went as well as how far the bird went in feet, which you wouldn't know it's in feet. The only reason why I know is because one of the questions, if you flip over your paper, says, when he is 15 feet away, how high is he flying? So I know that the units are in feet, but again, if you wouldn't have seen that question, if you don't know the units, you can just call them units. But if we know the units, it's good to name them by our units. So it's good to know that we're working in feet. Okay, so I'm going to walk you through this activity. You will need this nifty paper to do the activity. So let's get talking about these angry birds, their flight paths, and their quadratic equations that model their flight paths. Okay, so it says, what is the same about the two equations? So we're going to be looking at these two equations. Do you guys spot anything about these two equations that are in common? So think about it for a minute. What are some things that you notice are the same between these two equations? Okay, well, one thing we know, since the highest exponent is 2, what kind of polynomial are each of these equations? Which I already kind of gave it away. All right, so the highest degree is 2, so these are degree 2 polynomials, which means the proper way to say degree 2 is a quadratic. So both of them are quadratic. All right, something else to take note of, if you notice, how many terms do each of the equations have? They both have 3 terms, which remember the fancy way or the proper way to say that is they are both a trinomial. Okay, something else to keep in mind. What do you guys notice about both of the a values? What type of sign do each of the a values have? They both have negative signs. So my a value is negative, which means it's less than 0, which means they both have maximums, which it's also easy to tell that because the parabolas are facing down. All right, let's see here. Something else that I notice about the two graphs. Do you guys notice anything in common between the c values? The c values are the same. So the c values are the same. And if you guys remember, when we're in standard form, what do the c values represent in your graph? The c values represent the y-intercept when you're in standard form. So that means the y-intercept, I'm going to abbreviate, y-intercept is the same or are the same. Y-intercepts are the same. Okay, and I think for the most part, that's about all I noticed. If you notice anything else, though, please feel free to share. I'd love to hear. Okay, so again, we're just looking at the two equations, trying to get familiarized, there we go, with the two equations before we start answering some questions. Okay, so the first one says, what does the y-intercept represent? Okay, so in this scenario, what do you guys think the y-intercept right here represents in terms of this situation? Okay, well, if we're talking about this is the distance that the bird has traveled, and this is the height, what would this be if we're located at the point, let's see, we're at the point 0, let's see here, 1, 2, well, we should know because the y-intercept is the c value, so 3.5. So if the x value is 0, how far over have we traveled? We've traveled 0 distance, okay? And we are already starting at 3.5 feet high because y is going to be how high the graph is. Guys, so this represents where the bird starts, its start point. Guys, typically with quadratic application problems, our y-intercept is going to represent the start point of the problem, where the problem starts. Okay, because we can't really start at a negative distance. I mean, you can kind of start at a negative distance, but it doesn't really make a lot of sense when we're talking about the flight path of a bird. So just keep that in mind. Usually the y-intercept will represent the start point. So in this case, it'll be where the bird starts before it is launched. So where the bird starts before it is launched. Okay, I'm going to separate it because there's another question. Okay, so that's our start point. What part of the equation gives you the y-intercept? Well, I already kind of gave that away. Remember, what part of our standard form always tells us the y-intercept? Well, that is the c-value. So the c-value tells you what the y-intercept is, which in this case, c equals 3.5. Okay, so in terms of this problem, we know that the bird starts at 3.5 feet in the air. So if you wanted to add that, you could say the bird starts at a height of 3.5 feet. Okay, so we know the bird's kind of in the air to get launched, which makes sense because the catapult's got to be standing on something in order to launch it. It would be really hard to launch it from the ground because then it'd be really hard to like pull back the catapult to launch the bird. Okay, so the bird is starting at a height of 3.5 feet. Okay, the next question says, what do the x-intercepts represent on the graph? Okay, well, if the x-axis represents how far the bird has flown, okay, what does it represent? Really, the only one we care about is over here, okay, which this one didn't quite make it, but we know it would keep going. Okay, so looking over here, what do the points over here mean when the bird is being launched through the air? Well, it's flying, it reaches its highest point, it comes down, and then what happens when it hits right here? It's going to hit the ground. Okay, so your your x-intercepts are going to represent when the bird hits the ground, or at what distance the bird is at when it hits the ground. So this represents when, not really when the bird hits the ground, because that would mean that one of our axes would be time. Okay, so in this problem, it's going to mean how far the bird flew when it hit the ground. Okay, if x represented time, which as far as I understand, the x in this problem is going to represent how far it has gone. But if x represented time, then it would be how long it took the bird to hit the ground. Okay, which looking at the problem, it doesn't seem like, yeah, so like if you flip the page, it says how far away from the catapult is he when he's the highest. So since the x is representing the horizontal distance, that problem kind of helps you to know that, well, this is talking about length, not time. Okay, so again, this problem wasn't very descriptive. It wasn't very helpful at the start. You kind of had to like look ahead to figure out what's going on. So looking at that, this represents the horizontal distance. So the x-intercept would be, well, how far over was the bird when it hit the ground? Because this point, let's see, like this one, for example, is at the point 21, 0. Okay, so this would mean the bird flew 21 feet. And I know this is when it's hit the ground because y represents the height. So if the height is 0, that means that's when the bird is on the ground. Okay, so again, the x-intercept represents how far the bird flew when it hit the ground. Or maybe when it landed. You know, birds are kind of graceful, so it probably gracefully landed, not just like slammed and hit the ground. But you know, I'm just going to say it's when it hit the ground. Okay, so sometimes, you guys, again, the x represents time. So sometimes it would have been like, well, it took 21 seconds for it to hit the ground. But in this case, we know the bird flew 21 feet before it hit the ground because we know the problem is talking about distance and not time. Okay, question 4. Let's keep going. The highest part of the bird's flight is represented by what part of the parabola? Okay, so what part of our graph represents the highest point of the bird's flight path? Okay, well, in both cases, like this flight path would be this point, which is the point 9, let's see here, 9, 8. Okay, and then for this graph, it'd be somewhere, it's kind of hard to tell, somewhere like, right, I'm going to say about there. Maybe a little bit closer over here. So that would be at the point, let's see here, 10, 11, 12, 10, about. This one's probably more over here, but, you know, somewhere around there. Okay, but anyway, so, well, actually, yeah, it's probably more right here, actually. Sorry, guys. So this is more like the point, let's see here, 11, 10. Okay, so we'll just cross that out. JK, 11, 10. Okay, so anyways, what points are these on your graph? What is that point called when we're at the maximum height? Well, that would be your vertex point. So, the highest part of the bird's flight is represented by the vertex, which is your H and K. Now, if I want to know the height of the bird, because it says the highest part of the bird's flight is represented by what part of the parabola? Well, the highest part is represented in the vertex point, but more specifically, which value tells you the height of the bird, the X or the Y? Okay, well, Y is going to be your height, you guys. The X, we already said, is the distance traveled. Okay, so the Y value in your point, which in the vertex point is the K, this is the height, this is the distance. Okay, so the actual value in the vertex point that tells us how high the bird flew was the height. So if we want to know the highest part of the bird's flight, this would be more specifically the K value. Okay, the K value is going to tell us the height because that is the Y value of your coordinate. Okay? All right, now question 5. For the next several questions, use the h of x equation. Okay, so h of x, I cannot talk today. Sorry, guys. The demon cats are getting me. Okay, so in the next questions, we're going to be focusing on this equation, which is represented by the dashed graph. So we're only going to be looking at the dashed graph for the next couple of questions. Okay, so question 5. How far does the angry bird fly? So I want to know how far over did the bird fly? What was the farthest it traveled? Well, we already kind of found this out. This is when the bird hit the ground. So the furthest the bird went would be at this point, which value represents its distance, the 21 or the 0? Well, it'd be the 21 because that's the x value of the coordinate. So we already know the answer to that. We're golden. Guys, so the point is 21, 0. That's when it hits the ground. So how far the bird flew was 21 feet. That's how far over the bird went. All right, so now you guys are going to flip your paper over because I'm assuming I copied it onto the back to try to save paper. Okay, I'm just going to show you the back like this, and I'm going to have the graph displayed so it'd be easier to discuss the problem. Okay, so it says how far away from the catapult is he when he is at the highest? Guys, so I want to know how far over the bird has flown when it is at its highest point. Okay, so which point on this graph represents when the bird is at its highest point? Well, that would be the vertex point. So we know it has to do with the vertex point. So the vertex point is 9, 8. And this wants to know how far away from the catapult. So how far over, is that an X or a Y value? Well, that would be an X value. So which one of these values represents the X value in my vertex point? That would be the 9. Okay, so how far over when the bird is the highest is 9 feet. Okay, then we want to know how high does he go? Well, again, when we know the bird is at its highest, that's the vertex point. So we're looking at the vertex point again. And which one of the values represents the height of the bird? The 9 or the 8? Which one represents height? The X or the Y? Sorry. X or Y? Well, it'd be the Y. Okay, so the Y value of my vertex point would represent how high the bird went, which in this case is 8 feet. Okay, then it says when he is 15 feet away, how high is he flying? Okay, so when the bird is 15 feet away, we want to know how high the bird is. Okay, so this represents an x value. When he is 15 feet away from the catapult, that is a horizontal distance. But I want to know, well, how high is the bird when the bird's 15 feet away? So we're trying to find the y value. So to figure out how high he's flying, this is a y value. So I want to know, well, what is the y value when x is 15? Okay, so I'm going to go over to 15, which is right here. Then if I go up to my graph, I want to know, well, what is the y value at this point? So I'm going to go over to the y-axis. It hit the y-axis, or it's not hitting the y-axis, but the y value at this point would be at 6 feet. Okay, so the bird is 6 feet high when he is 15 feet away. All right, there you go. So that's our first scenario. Okay, after that, we are then going to be discussing this other scenario. So I hope you guys have just as much fun with this next scenario.